Okay, we're at this is part B, section 1.2, the questions. Again, if I were looking at this over here and this was a competitive exam, certainly I'd be very nervous about it, but I'd be looking around for what I call low-hanging fruit. And certainly low-hanging fruit for me, I'm looking at it, one looks tough to me, I'll be honest with you. Two doesn't look that bad, it looks like an algebra problem. Three looks like a simple geometry problem. And then I'm going to say the other ones, probably, like four looks like a long reading one. Five looks like a little bit, it's not that long, but more reading. And one's that sequence. So what I want to do is I want to cut to the chase. So if I were doing this, I would look at two. I would do two first. Now I'm going to go to the blue area. This is the key. And I'm going to talk through it. All right. So the problems are written here. And if I were reading it, it says the sum of the two numbers is 11. Now, if I were reading that, I'd say the two numbers have to be, the first number would be 11, the next number would be 11 minus x. So I'm reading that, and I got that part covered. And it says the cube of their sum. Well, their sum is 11, so the cube of their sum is 11 cubed. It says the cube of their sum exceeds the sum of their cubes. Well, let me write this down. This is x cubed plus 11 minus x cubed, and it says it exceeds it by 792. All right? I just want to look at the k, and I want to make sure you know what I'm doing over here. X, 11 minus x are the two numbers, and then I wrote an equation down. Now, once I do this over here, I'm going to say, this doesn't look bad to do. Now, what I don't want to do is I don't want to waste time with a lot of arithmetic, though. So what I want to do is I want to go through it now for you. And for me to do this, I certainly would need to know the binomial theorem to expand it. And I'll write this over here. It's 11 cubed equals x cubed. And then I'm going to expand that binomial. I need to know the binomial theorem to do that. That would be 11 cubed. And then what do you get? You would get minus 3 times 11 squared x. Then you would get 3 times 11 x squared, and then you would get minus x cubed, and then you get 792. Now, what do I notice about this over here? I noticed something pretty nice about it. Like, for example, I could subtract 11 cubed from both sides, and that's gone. The other thing I noticed nice is x cubed minus x cubed is gone. So what am I left off with? I'm left off with something pretty simple, and I'll write it down for you. I'm left off with 0 equals, well, I'm going to write it in order, so it's 3 times 11 x squared, that's this guy written down, minus 3 times 11 squared x, that's this guy written down, and then plus 792. The next thing I would do is, just to get the numbers to be a bit smaller, is to divide both sides by 3. And you get 0, because 0 divided by 3 is 0, 11x squared minus 11 squared x plus. Now, let me point out 3 goes into, I know it goes into 792. And someone says, how do you know that? The sum of the digits is 18, and 18 is divided by 3. So 792 is divided by 3. That goes in what? I'm going to say 2. That would be 6, 1, 9. And 3 goes into 19 6 times. That's 18. And then you get 1, 2, which is 4, 264. Now, I'm starting to realize that there's a really good chance that 11 goes into 264, all right? Let me just erase my baby arithmetic over here. I don't really need that anymore, all right? So I'm going to say that looks fairly simple to do, but let me write this down for you. 0, so it's going to be x squared. I'm dividing by 11 now, minus 11x plus. Now, again, I want to point out what I mean by that. 11 into 2, 6, 4, 2. 22, you can do that in your head, by the way, 44, 4. So it goes in 24 times. All right, let me erase my baby arithmetic. And let's continue. And what do you get over here? 0, x and x. And 24, what 24, 3 and 8, right? And that's going to be x equals 8 or x equals 3. What was our question, though? Find the two numbers. Well, let's see. The two numbers are going to be x and 11 minus x. So if x is 8, what's 11 minus 8? 3. Now, if x is 3, what's 11 minus 3? 8. So what are the two numbers? 3 and 8. This worked out pretty nice. All right? So, someone's going to say, going back to the original question set, I'm definitely saying 2 is low-hanging fruit, all right? Really easy to do. So we're done with 2, and now I'm going to go to number 3. All right, number 3 is wire, right? So a wire is in the form of a circle whose area, oh, gee, I know area of a circle, right? So what's an area of a circle is pi r squared. So to say the area of the circle is going to be 3 root 3 is equal to pi r squared. All right? And I think I can figure out r. It may not be important in the problem, but I can do this pretty quickly. It isn't like a struggle for me. So I'm going to say, well, let's say I'm going to write this a little differently. I'm going to write this as the square root of, I'm going to bring the 3 on the inside, so it'll be a 9, 27 over pi would be equal to r squared. And I know r is a positive number, by the way. So r is going to be what? Well, it's going to be the square root now. So the square root of a square root is a 4th root. So I got the 4th root of 27 over the square root of pi. And again, it's a nasty number. There's no doubt about it. All right? Now, I'm just reading it. And again, I'll go back to the blue areas in a second, by the way. So I just kind of read it, you know, wire in the form of a circle. I read this part over here. I got this. Then they say the wire is bent into an equilateral triangle. Well, you know what I got to do? I need to find out the circumference of the circle because that's how much wire I have. And the circumference of the circle is 2 pi r. Circumference of the circle is 2 pi. What's r? It's the 4th root of 27 over the root of pi. All right, now someone says, you got the circumference? I do, and I'll write this down for you. The circumference of this circle is going to be 2. Well, pi divided by root pi is just root pi. And then you get the 4th root of 27. All right, now I got to understand the question now. They're taking the circumference of the circle and they're bending it into an equilateral triangle, which means the sides are all equal length. And if this is the circumference, I'm just going to take a third of that. So yeah, every side is going to be this, 2 root pi, 4th root of 27 over 3. But what do they want to know? They want to know the area of the triangle. How do I do that? I got to get the altitude of it. And what's the angle over here? That's altitude, 60 degrees. Whoops. So let's write this down. Sine of 60 degrees, and that's going to be root 3 over 2, is going to equal the altitude divided by the length. And the length of this side is pretty simple. What is it going to be? 2 root pi, 4th root of 27 over 3. And I got to get the a now. And how are you going to do that? Let's write this down. So root 3 over 2 times 2 root pi, 4th root of 27 over 3 is what a is equal to. And I'm going to simplify that. I notice immediately that this cancels off, and this would cancel off to root 3. All right, looks tough though, doesn't it? Let's write this down. What's the altitude going to be? And I'll be very careful. Pi, 4th root of 27, and you get root 3 on the bottom, and that's what a is. Now what's the area of the triangle? It's 1/2 times the base. This is the base, 2 root pi, 4th root of 27 over 3. This is the area now of the triangle. I'll put AT there. So 1/2 times the base times the height. And what's the height? It's the altitude. And what's the altitude? Root pi, 4th root of 27 over the root of 3. I guess I got to do the arithmetic now, don't I? So let's talk about it. I notice the 2 cancels off immediately. And I notice that root pi times root pi is just simply pi. I got troubles though, and I'll tell you what the troubles are. It's that other computation, and I don't want to do too much work. I'm going to write everything in terms of threes. So this would be 3 to the first power, this on the bottom, by the way, and 3 to the half power. And then what do you get? This is going to be 3 cubed, but you're taking the 4th root of it, so 3/4. And this one's also going to be 3 to the 3/4. And I want to do the arithmetic, and I want to see what I get. So it's going to be pi. Let's see what you get there. You get 3 to the 6/4. I'm doing the top now. And 6/4 is 3/2. And what do you get on the bottom? It's remarkable. You get 3 to the 3/2. What is this going to give you? Pi. All right. Now, granted, that might have been tough with the manipulation with the numbers and stuff, but I want to go look at the key, and I want to see if they've got that. All right. There's work down for them, and I'm seeing it. All right. So, someone says, "What are you going to do now?" I got to pick another problem, and certainly on a competitive exam, you don't have an answer key, but I got to pick another problem. And someone says, "What problem are you going to pick now?" Well, I got to do 1. We've already done 2. And we've done 3. There's 4, and there's 5. I think I'm going to pick 1. Now let me just go into the blue area because I'm kind of running out of room. And what I'm going to do is I'm going to start to write down a sequence of events I'm seeing over here. And this is about what P is. So I can say P1 would just be the number 2. And P2 would be 2, and then I'd have the square root of 2. And if I wrote this down, this would be 2, and then it'd be 2 to the 1/2 power. Now, if I put down P3, it's more difficult, by the way. What do you get? Well, I want to point out what that's going to be. It's going to look like this over here. So if I wrote that down, what would you get? You would get 2 square root, I'll write this down for you, 2, and then the cube root of 2. All right, so I still get, I'm looking at it, I'm still getting, by the way, this is a root. I'll put this down just to make sure there's a 2 there. Let's see, that'd be 2 to the 1/2. And one of that's, it's kind of rules of exponents now, and it's going to be times 2 to the 1/6. Let me keep going, P4. And what would that look like? I'm kind of moving out to this over here now, and it's really tough to write down. I did type that up, by the way. And what do you get over there? Right? They're really kind of crazy looking, aren't they? You're going to get, let's see, 2, and then you're going to get the 4th root of 2. I think I'm getting a simple pattern now. 2 to the 1/2. 2 to the 1/6. I'm still getting that, by the way. And then you're going to get what? 2 times 3 times 4. That's going to be what? 24, isn't it? I'm starting to recognize these numbers, by the way. And so I'm going to just march off to Pn now. And what's it going to be? 2 to the first power, 2 to the 1/2 power, 2 to the 1/6 power, then 2 to the 1/24 power. I want to point out what these numbers are, and let me just point this out to you. Whoops, I didn't mean to do that. This 2 here is 2 factorial there. This 3 factorial here, I'm sorry, this 3 is 3 factorial there. This 4 is 4 factorial. So what are you going to get? We're going to march out to n factorial now. And let me write that down for you. Two to 1 over n factorial. And I'm going to write this down. So Pn is going to be 2. Let's write this down. It's going to be 1 plus 1/2 plus 1/6 plus 1/24 plus yada, 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 all the way up to 1 over n factorial. Again, you may or may not recognize what we're looking at over here, but I'm looking at the exponent, and I want to point out what I mean by that. We're just looking at this thing over here. And this looks familiar to me, and it should look familiar to you as well. So I'm going to say it has something to do with the number e. And what's e? E is actually 1 plus 1 plus, let's see. You know, so I noticed I made a mistake in my notes, but that doesn't matter. I'll come back and I'll probably correct that later. So it's, you know, maybe I should write these down for you. 0 factorial, 1 factorial. This is e to the first power, by the way. This is going to be 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus, it goes on forever. All right, so I got a good idea now that this has something to do with the number e. So let me write this down. E is 1 plus 1 plus 1 over 2 plus 1 over 6 plus 1 over 24. And I apologize. I made a mistake in my notes, by the way. I notice I have, you know, this written down correctly, but then I failed to write this down correctly. And something's missing over here. What's missing over here? Well, it's going to be 1/6. That's missing. Sorry about that. All right? So I'm looking at this thing, and I really don't have it. And I'll tell you what I mean by that. I have this part. Right? So what's it going to be? It's going to be that part that I have, you know, that goes off over here to 1 over n factorial, is really just going to be, and n goes on forever, by the way. It's an integer, goes on forever. This is really just e minus 1. All right, and that's going to be 1 plus 1/2 plus 1/6 plus 1/24 plus yada, yada, yada. All right, so I have p now. And what's p going to be equal to? Well, it's going to be 2 raised to the power, let's write this down, e minus 1. All right, now someone says, I don't know what their question is. Well, I got to go back and read it. All right, so it says given. And this took me a lot of time to think through, by the way. What do they want to know? They say p. Well, what are they saying p is equal to? They're saying it's a to the e over b. Then they want to say a and b are integers. Well, I think I'm seeing it. And what's it going to be? 2 to the e over 2. Let me see if I did that right. Yeah, I think I did it right. So it says, for positive a and b, what's a plus b? Well, a equals 2, and so does b. So what's a plus b? It's 4. All right? So we did it right. All right, so that's what we've done so far. We've done 1. We've done 2. We've done 3. And now I'm going to try to do 4. Now I'm going to talk you through it. As I talk you through, I'm going to read it. It says a Ferris wheel at a carnival can carry 4 passengers in each car. So I'm going to say there's n cars. Now, I'll hold off on that. Maybe I shouldn't say there's n cars. So let's take a look. On the first trip of an evening, the passengers seated 4 in the first car. Let me write this down. There's a car. There's 4. Right? And then it says 2 in the second car. And then the third car, let's see. I got to read this too. On the first trip, 4 in the first car, 2 in the second car, and 1 in the third car. Whoops. All right. And then it goes on and says the same arrangement then continues around the Ferris wheel. So what does that mean? He keeps doing it. 4, 2, 1. And he keeps doing it. 4, 2, 1. Yada, yada, yada. He keeps doing it. But it's got to maintain the pattern, and he fills up the whole thing. Right? Maintains the pattern. So let's just make sure we understand what's going to be. The same arrangement continue around the Ferris wheel. All right, so let me see. I'm going to just simply say how many cars there are. And I'm just going to say that this is the first group, this is the second group, this is the third group, and he does this n. I don't know what the n is, by the way. So how many cars are there? Number of cars. Well, the number of cars would be what? Well, each group has 3 cars in it, so there's 3n cars. Now, how many people? The number of people. All right, this is, let's see, there's 4, 6, 7 in every group, right? So there's 7, and there's how many groups? There's n. So n is the number of groups. All right. Well, I don't even know what the question is at this point. Then what happens is, it says over here, the same arrangement is around. We got that part. When the trip was over, 2/3 of the passengers remained on, right? So let me just make sure I understand what we're reading over there. It says 2/3 of the passengers remained for the second trip. Right, so let me write that down. 2/3 remained. All right, 2/3 remained. So if this is the number of people on, 2/3 of those remained. All right, so the number of people remaining. It's 7 over n times 2/3. That means 1/3 of the people got off. All right, let's keep reading it. 2/3 of the passengers remained for the second trip, and 3 times as many got on as got off. Well, how many people got off? The number of people that got off. Well, 1/3 of 7n got off. All right, let's go back and read. So 2/3 of the passengers remained on the second trip, and 3 times as many got on as got off. So 3 times as many got on as got off. So how many people got on? Well, it's 3 times this number, right? So that's going to be 7n got on. All right, let's keep moving. Wow. So how many people are on the car now? This is the second run, by the way. So let's take a look. And I think I said the number of people that remain was this, right? So that's going to be 14n over 3 remained. And then more people got on, and 7n is what got back on. Right, remember, they got back on now. Right, let's write this down now. And how many people are on now? Let's see, 14n plus 21n over 3. And that's going to be what? That's going to be 35, right? Let's go back and read. So, 2/3 of the passenger remained on the second trip, and 3 times as many got on as got off, leaving half of only 1 car vacant. All right? So I want to make sure you know that the total number of seats. So, I know there's n groups, and in each group there's 6. I'm sorry, I made a mistake there. So there's n groups, and each group can hold how many? 12, because each car can hold 4. All right? So that's a total number that can be held. But what does it say over here? It says leaving half of only 1 car vacant. So what do I know? I know I have to take 2 from that number. And this is the number of people on the Ferris wheel now. So I'm going to write this down. That's 12n minus 2. So 12n minus 2 is the number of people on the Ferris wheel. And what's that equal to? This number, 35n over 3. Well, let's hope things work out nicely now. And what do you get? 35n equals, let's see, 3 times 12 is 36, right? Minus 6. And let's see, I get minus n equals minus 6, or n equals 6. Now, what's their question now? How many passengers could this ferry wheel carry? Well, I know now, because if you think about it, we have n is 6, right? And what's n? N is the number of groups. And what's each group hold? Well, 4, 4, 4, 12. And 12 times 6 is going to be 72. So it can hold 72. All right, let's see what they got for an answer. Yeah, 72 passengers. All right, let's go back to the original problem set and see what we've accomplished so far. 1 was tough. 2 was pretty good. 3 was pretty good. 4 is not bad. Let's go to 5 now. All right. Now 5, it really doesn't look that bad. I'm kind of running out of room. Let me go to 5. Now 5, right, the coefficient of a second degree quadratic equation is 1. So let me write this down. So what's it going to look like? It's going to look like x squared plus bx plus c equals 0. Because the coefficient of the x squared term is 1. It says if the constant term of this quadratic equation is increased by 1, if it's increased by 1. Well, that's a big if, right? It says if, this is a really big statement over, if the constant is increased by 1, the resulting equation, the roots would be equal. Let me see if I can understand what that means, by the way. So let me, and I really mean that. Do I understand what that means? Well, let me write down the roots of this guy here. And the roots would be x equals, let's see, the opposite of the b, plus or minus, that's going to be tough, right? So b squared minus 4, well, the a is 1, and the constant term is c plus 1. And that would be over twice a, and the a is 1. So if the roots are equal, what do I know? I know the discriminant, b squared minus 4 c plus 1 would have to equal 0. So I know that much. And again, for the roots to be equal, that has to be the case. So I'll write this down. So b squared minus 4c minus 4 is equal to 0. I could also just simply say b squared would have to be the same thing as 4c plus 4. All right, I still don't know what their question is, but they did make that statement. All right, so I'm going to say that's not so bad. I got that part. Then they go on to say something different. They say if the constant term was diminished by 3. Let me point out what I'm talking about over here. All right, let's write this down. So what do you get over here? Let's write this down. X squared plus bx, whoops, doesn't look like a b, does it? Plus, they say the constant term was diminished by 3. All right? What are they going to say? They said the resulting equation is the roots of this resulting equation, the roots would be double, all right, of each other. All right, so one is twice the other. All right, it's probably, I don't know, I got to think about this now, don't I? So the other one was pretty easy to think about. I want to point out my result of this one over here. I got this guy. And let's think about this one, all right? So, thinking about it, I'm gonna just talk about roots being double. Let's write this down. Now remember, if you're on a competitive exam, the clock could be ticking. At any point they could say, pens down, and they collect your exam. If they collect your exam now, at least you have something written down where they could give you credit for something that you've written down. Like they might say they're looking for this in a key. That might be a bad thing, not a bad thing to have. But I want to keep going, all right? The buzzer hasn't rung yet. Let's take a look at it. I'm going to say an exam like this would probably be a 60-minute exam. They wouldn't expect people to finish it, though, all right? Now, certainly some people could finish it in 10 minutes, but, most people are not going to finish anything in 10 minutes, right? But here's the deal. I'm gonna try to write the roots down for this. Let's see, the opposite of B. I'm looking at this over here. Let's see, that would be minus B, plus or minus. I go at the bottom now, just 2, right? What do you get over there? Let's see. B squared minus 4. A is 1. And the constant term is C minus 3. All right, so I'm kind of moving. And I know there's going to be 2 roots here. I'll write them down for you. I'm going to have to go to the next page in a second, by the way. And, certainly I'll put down root 1 here, which can be minus B, plus or minus. There's 2 in the bottom. Oh, you know what? Maybe I shouldn't do that. I'll put plus. This would be B squared minus 4C plus 12. Oh, that doesn't look right. And what's the other root going to be? R2 is going to be minus B minus, let's write this down over here, B squared minus 4C plus 12. But there's all kinds of tricks you could do with this. I'm kind of looking at this, and I'm wondering, one of the roots is twice the other. So one of these roots is twice the other. Let's think about that. So I'm going to say, I'm going to write this down, so twice the other, right? And that's where you could probably get a little stuck here. So one root is twice the other. Well, if the clock is ticking, at least you're in a good spot when it's ticking. It's ticking and you're very close to the end of it. And you might take a stab at it at this point. But I don't want to take any stab at it. You know what I want to do? I'm going to do something crazy here. I'm going to take this, and I'm going to plug it in over here now. So let's write this down. R1 is minus B plus, well, that's 4C plus 4 is what B squared is, right? So I hope you realize that B squared is 4C plus 4. And I'm doing a discriminant. That's minus 4C plus 12. So these things would cancel off. What do you get? 4 and 12 is 16, right? And the square root of 16 is what? 4 over 2. And what's the other one going to be? It's going to be minus B minus 4 over 2. All right, let me keep going. I'm getting closer and closer, warmer and warmer. So let's take a look at it. And let's just do something, I don't know. I guess I'd have to double one of them, right? Let's double this one. So what's 2R1? Well, that would be minus B plus 4. And my claim, that would be equal to the other one, which is minus B minus 4 over 2. All right, let's see what happens over there. What do you get? Well, you get minus 2B plus 8 equals minus b minus 4. Well, it's getting easier for me, isn't it? So I would get b equals 12. That's a possibility, right? Let's do the other one. Let's double this one. And what would you get over there? You would get minus b plus 4 over 2. And if I double the other one, you get minus b minus 4. And what does it give you? Minus b plus 4 equals minus 2b minus 8. And you would get b equals minus 12. I got two different results. And this is good news. So b could be plus or minus 12. Don't be discouraged. I want to get to c, though. And what's the c going to be equal to? Well, I got this over here, and this is really important to have this over here. So the b squared is going to be 144 equals 4c plus 4. I want to see if I get the c here. I'm going to divide both sides by 4. So c plus 1. And 4 into 144 would be 36, right? So what's c going to be equal to? C will be 35. So I got two different equations now. What are they going to be? You know, quadratic equation would be x squared minus 12x plus 35 equals 0. That's one equation. The other one is x squared plus 12x plus 35 is equal to 0. All right, buzzer's about to go off. Let's see if we got it. Yep. Yep. Okay, I want to point out when you're looking at my work, you might say, oh, your work looks so different than what you just did today. Tomorrow it looks different. There's a whole bunch of variations on how you could do problems. And that's what sometimes people look for when there's a competitive exam and there's a comparison between two people's exams. They look for the most elegant solution. They may look at my solution here today and say, gee, this isn't as good as the one in the blue area. And that's something to be careful about, that some people can do things much more efficiently than others, all right? And, you know, certainly one day I might do it one way, another day do another way, but the bottom line is all paths, they should lead to the final result. Thank you for paying attention.